Hello, HISD students. My name is Mr. Vivas, and this is the third week for Math at Home. For our middle school math, we are going to be dividing in 3 sections. For the 6th graders, we are going to have or continue order of operations, and we're going to focus on exponents. For our 7th graders, we are going to be talking about operations with fractions and decimals. And for our 8th graders, we will be learning about arithmetic and algebraic properties. The first thing I want to talk about is the objective for our 6th graders. And is for them to be able to learn how to use order of operations to find and generate equivalent numerical expressions. And before we get into the practice, we need to go over some key vocabulary. The first one is going to be base. And when we have an exponent, we have a number that is the biggest one, and that's called the base because that's the one that is going to be multiplying by itself. Then we are going to have also the actual power, and this is that little number that is on top, and this number just indicates how many times the base will be multiplied. So that means that, for example, 10 to the power of 2 is actually 10 times 10. So the 10 multiplies itself 2 times. In order for us to be able to review what we learned last week, we have to go back to our acronym that was called PEMDAS. And remember that we discussed this as the order of operations when you have a mathematical expression. So the first thing that you have to tackle is the operation inside of the parentheses. After you finish that, then you have to focus on the exponent. After that, you have the same priority for multiplication and division, and if they are in the same expression, you just have to go from left to right. And then you have also the same priorities for adding and subtracting. And again, if you have it in the same expression, you just go from left to right. Now let's go to a real world problem so we can use PEMDAS in order to solve this riddle. It says, Pedro and 3 friends make a tutorial video. Each friend emails the video to 3 new friends. These new friends forward the video to 3 more friends. If no one received the video more than once, how many people will receive the video in the second wave of emails? Let's get started. Pedro and his friends did the exact same thing. So that means that I can see what Pedro did by himself and then just multiply it times 4. So let's see what Pedro did. Pedro sent 3 new friends an email, and then his 3 friends sent another 3 people the video tutorial. And I want to know how many people in total got the video on this second wave. So I can see that there is a pattern here. On this one we have 3 people, and then on this one we can write the expression 3 times 3, or another word to write it will be 3 to the power of 2. So I can further say that this behavior was done 4 times because it was 4 friends that did this exact same thing. So now it comes the order of operations, where I don't know if I have to multiply 4 times 3 first, or what do I have to do. And this is where we have to remember PEMDAS. So the first thing that I have to tackle is the exponent. So first thing that I have to do is multiply 3 times 3, and that's gonna be 9. Once I multiply times 4, then that's gonna give me a total of 36. So my answer will be 36 people will receive the video in the second wave of emails. Now we are going to have a couple of seconds for you guys to write the complete sentence answer using the sentence stem. Great. And your answer should be something like the one on the screen. It's your turn. You have a problem on the screen, and I'm giving you also a sentence stem in order for you guys to write a complete sentence answer. You're gonna have a full minute in order to try this problem at home. If you don't have time, you can complete it after. Make sure that you take a picture if you did not have time to complete it. So now we get to our 7th grade section, and the objective for our students is to learn how to add, subtract, multiply, and divide rational numbers. Specifically, today we will learn about fractions and decimals. But before, I just want to do a quick review on some key vocabulary, and the first one is a numerator. When we have a fraction, the numerator is just the number on top of the line, and it indicates a part of a total. In this case, the 2 is part of a total 3. The next word is denominator, and this is just the number below the line, and this indicates the total of our fraction. Let's get to our real world problem now. Dina works at a pizza restaurant, and while picking up the leftovers, she realizes that there is 4 boxes left that each contain only 4 slices out of a total of 8 slices. So if you put them together, how many pizzas does she have left? Let's see how we do this problem. Dina found 4 boxes that each one is gonna look like this fraction. So I'm just gonna add each box, so then I will know how many pizzas she has in total. So I can choose to group this addition, and then I'm gonna add my fractions. Remember that if the fractions have the same denominator, I can just add the numerators and keep the denominator the same. So what does that mean? That means that the denominator is going to remain to be 8, and I just add 4 plus 4, And then I'm gonna do the same thing on this side, where the denominator is gonna stay the same and the numerator is the one that is gonna be added. I can then add those two, and that's gonna be equal to 8 over 8 plus 8 over 8. And I can just simplify the fraction. I know that 8 divided by 8 is the number 1 plus 1. So that means that the answer will be that she has 2 pixels left. Let's look at this problem, and it's just for you guys to be able to see what happens if I'm actually subtracting. So let's say that she has on one box 6 over 8, and she eats, that's the symbol of subtract, only 1 out of 8 slices. So how many slices does she have left? Well, the subtraction works the same way as addition. The denominator is going to remain the same, and I'm only going to subtract the numerator. 6 minus 1 would be 5, and this will be my new result, which is 5 slices out of 8 slices on a pizza. I'm gonna tackle this problem different so we can see the multiplication of fractions. So I know that each box has the same amount of slices, and I can just multiply by 4. So you can see that I have a fraction times a whole number, and we have to remember that every whole number can be expressed as a fraction by adding a denominator equal to 1. So now we just have to think how to multiply these two fractions, and this is very easy. We just have to multiply numerator times numerator, denominator times denominator. 4 times 4 on the numerator, and 8 times 1 on the denominator. That will be equal to 16 over 8. And if I divide this, 16 divided by 8 is 2. So I'm gonna get the same answer. She will have left 2 pixels. Let's look at another question that might be asked. And this is where Dina found a box with 4 slices, and she has 2 friends that she wants to give these slices to. And the question reads, how many slices will each friend get? Well, actually, now we are talking about a division problem, and we have to divide it by 2 friends that she has. As before, we said that every whole number can be expressed as a fraction by adding a denominator equal to 1. So I can do the same thing on this one. But now we are talking about division, and this is what we need to do. The strategy is called KCF, and this reads keep, change, flip. This is what it means. We are going to keep the first fraction the same. We are going to change the division sign by a multiplication sign, and we are going to flip the second fraction from 2 over 1, and we're gonna make it 1 over 2. So this is a way to tackle division of fractions by using KCF. So now we can do this as a multiplication. We said that this is very straightforward. We multiply numerator times numerator, 4 times 1, and denominator times denominator. So this will be 4 out of 16. We can then simplify 2 out of 8, or 1 over 4. So what does that mean? That each
friend will get one slice for every 4 slices, and that's gonna be the answer for our question.
Now we are going to change our problem so we can discuss the operations that we do with decimals. And now the problem reads: Dina works at a pizza restaurant, and while picking up the leftovers, she realizes that there are 4 boxes left. Each contains 0.25, 0.5, 0.75, and 1 pizza respectively. If she puts all of these pizzas together, how many pizzas does she have left? Now let's see how the decimal operations work.
Writing first the expression, we have 0.25 in one of the boxes, then 0.5, then 0.75, and then 1 whole box. So now remember that if we are adding, we can group them how we want. So I can group this side and this side. In order for us to add decimals, we need to make sure that both decimals have the same place value. What does that mean? Well, if I'm gonna add 0.25 plus 0.5, I have to make sure that I add on this empty space a 0, so both decimals are in the hundreds. Remember that decimal places when we are adding have to be one on top of each other. So I can just tackle just like normal addition, and I have my answer for the left group. I can then do the same here, and as I said, it's very important that we understand the place value. So the 1, since it's a whole number, will be right here, and we will have to add zeros in order for this number to be in the hundreds as well. I add normally, I get my decimal point, and now the only thing that I have left is to add the left and the right. I can just say 0.75, and then I'm gonna add the same. Make sure that all the decimal points are on top of each other. So this is going to be my answer. So I can say that she has 2.5 pizzas left. And it works the same for subtraction. So let's say that out of that 2.50 pizzas, Dina had some friends and came over and actually ate 0.75 of the pizzas. So I'm gonna make sure that the decimal places are one on top of each other. So this is the only way that I can do it. I'm gonna borrow from the 5, this becomes 10, then that's 5. I'm gonna borrow here from the 2, this becomes 14, that's a 7, and this means that she has left 1.75 of pizzas. Now that we worked out the problem, make sure that you are writing the complete sentence answer using the sentence stem that we have on the screen. I'm gonna give you a couple of seconds for you to finish this. Awesome.
Now we get to our 8th grade section, and the objective is that the students will learn how to use mathematical processes to acquire and demonstrate mathematical understanding. Specifically, we are going to be talking about arithmetic and algebraic properties. The first one that we will discuss is the associative property. And this says that when you add or multiply only those two operations, you can group the numbers in any combination and it will give you the same result. Let's see an example. If I have the expression 2 plus 3 plus 5, according to our associative, I can combine these in any way and it will give me the same result. So let's see if it's true. I'm going to start with the addition of 2 plus 3, and that of course gives me 5. And if I add it to the other 5, then my result will be 10. Now let's say that I start my problem, but I'm combining the 3 and the 5 first. That's gonna be equal to 8, and then if I add it to 2, it's gonna be 10 as well. So this means that the associative property does work. Let's see if it works for a real world problem. And the problem says there is a new theater in Houston, and the theater has 5 sections. Each section has 10 rows, which has 6 seats each. How many people can fit inside of this new theater? Let's work the problem and see if the associative property holds.
I can say that we have 5 sections. In each section, I'm gonna multiply, has 10 rows. And then I can multiply again because each row has 6 seats. Our associative property says that we can group the items in any order and we are gonna have the same result. So that means that I can start with this multiplication first and then multiply times 6, or I can do 10 times 6 and then multiply times 5, or I can even further say that I can multiply 6 times 5 and then multiply times 10. So any combination will give me the same result. Let's see how it works. 5 times 10 will be 50, and then I'm going to multiply 50 times 6, so that will be equal to 300. So that means that there is going to be 300 people that can sit on the theater. If I do it on this combination, then I'm gonna multiply 5 times 60, which will give me the same result. So that this proves that the associative property works for multiplication or addition.
Okay, now the next part that we are going to talk about is the commutative property. And this is just saying that the addition and multiplication can be done in any order. So let's see an example so you can see how it looks with numbers. Let's say that I have the multiplication 0.5 times 4. Or we can say that we have 50 cents and we have 4 50 cents. If we multiply the 50 cents times 4, it will give me a total of 2. Now, let's just reword it in a different aspect. And let's say that I have $4 and I multiply that times 0.5, or I just get half of it. Well, that is also equal to $2. So that's what the commutative property tells you. You can multiply or add in any order and it will give you the same result. Let's see how it looks in a real world problem. If I have a 30-minute window until my dad picks me up for soccer practice, and I have to clean my room and fold my clothes, and then I know that it takes me 20 minutes to clean my room and 10 minutes to fold my clothes, the question says, do I have enough time to do both? And would it matter on what order do I do it? Let's see how we work this problem.
I'm just trying to show you that on the commutative property, I'm gonna have the order is not gonna affect the result. So let's say that I'm gonna do first my cleaning, 20, and then I'm gonna do my folding, and this becomes 30 minutes. So if I do the cleaning first and then the folding, I'm gonna be done in 30 minutes. So that means that I'm going to have time to do this. What if I do it backwards? What if I do the folding first and then I do the cleaning? Well, as you can see, it doesn't have any effect on the final result. This is the explanation of commutative. This works only for addition and multiplication.
The last one that we are going to be talking about today is the distributive property. And this says that when I am multiplying the sum of numbers, this will be the same as multiplying each number and then adding the product. So let's see how it looks in our examples. If I have the expression 3 times the sum of 5 plus 2, I can just approach this number, this expression, as adding first 5 plus 2, which is 7, and then multiplying that times 3, which will give me the number 21. But the distributive property tells us that we can also approach this as the multiplication of each individual number times the number outside. So that means that I multiply 3 times 5 and then I multiply individually 3 times 2. That will give me 15 and 6. And if I add the products, then it will give me 21, which demonstrates that the distributive property works for this example. Let's see how it looks in a real world problem. If Eric wants to give $2 and a toy to his 5 siblings, how much money and how many toys in total is he going to give away? Let's look at how we work this problem.
On this example, Eric wants to give a $2 and a toy to his siblings. So I can say that he's gonna give $2 plus, I'm just gonna draw and a toy to his siblings. How many siblings does he have? Well, actually he has 5 siblings. The distributive property tells you that I can first add the symbols inside and then multiply by the outside number, or it's gonna be the same. I can multiply the outside times each of the numbers inside the parentheses, and I'm gonna get the same result. So what does that mean? That I'm gonna multiply first 5 times 2, and then I'm gonna multiply 5 times the second number, and then I'm gonna get the final product. So I'm gonna multiply 5 times 2, and that's gonna be $10 plus 5 times the toys. That means that he has to buy 5 toys. So my question said, how much money and how many toys in total is he going to give away? Well, my answer is gonna be $10 and 5 toys he has to give away for his siblings.
And we have reached the end of our lesson number 3 of middle school math. Make sure that you visit HISD at home if you need extra resources, and stay tuned for the next math at home. See you next week.